then I will reschedule to. If I reschedule the test to Tuesday, is that okay? Everyone free on Tuesday? What classes do you have Tuesday morning?
English. English
English,
doctor.
Okay, then Friday lah. Friday. We'll do the test on Friday. 10 o'clock. Yeah? Okay, so the test 3 and 4 will be next Friday. Yeah, 1 week from now. So it's going to be on the multiple differentiation as well as multiple integration. Okay. Right. So today we are going to attempt to finish everything up. Right. So we stopped at this example on Monday. So today we will look at today we will look at we will look at a few more examples basically today. All right. To continue on from last week, we will look at a few more examples, a little bit more complicated maybe. Okay. All right. Okay, so let's try this example. Just one example, maybe. Okay, and then I will move on to the last subtopic. All right. Okay. So double integrate sine x minus y dA. Okay. So the region is region bound by this y equals to cos x, y equals to 0, x equals to 0, x equals to pi over 2. Okay. So now, if you look at a question like this, okay, if I didn't ask you to draw out the region, okay, so in the last few topics, okay, I sort of tried to mention to you why you have to draw the region first, so that you can find the limits. Okay. Now, certain questions, for example, like this, it's a bit tricky, okay, to sketch. Okay, you can straight away go to the integration part, but how are you going to find the limits? How are you going to find the limits if you don't do the region? That's the tricky part. Okay, so on Monday I also mentioned something. Okay, so to determine what the limits are, first of all, you have to think about this. Are you going to do dx dy first, or are you going to do dy dx? Yeah, are you going to do dx dy or dy dx? So look at the limits. Okay, look at the limits. Now, if we do dy dx, sorry, if we do dx dy, yeah, if we do dx dy, what will the limits be? What's so if we do dx dy, that means we do dx first and we do dy second lah. Okay, now what are the x? What are the x limits in this question? Quick, I've given it. It's there.
0 and pi over
Correct.
2.
So you start from with limits, yeah. So with limits, you always have to go with a smaller value and then the bigger value. Yeah, so with limits, you always start from you always go from smaller to bigger value. Okay, so x equals to 0, x equals to pi over 2. Okay, what are the y limits?
Cos x and 0.
Yeah, correct. Cos x and 0. So 0 cos x. Okay, now. Okay, so we have this. If I do it the other way around, if I do dy first and then dx, what are my limits? Well, it'll be y limits first, right? So y limits the same, 0 to cos x, and then x limit is 0 to pi over 2. Okay, now based on the limits alone, can you decide which one you prefer to do?
Y dx.
Yeah, dy dx, right? You prefer to do this one, right? Not this one. Why you don't want to do with dy dx? Sorry, why don't you want to do dx dy?
Final answer dia ada variable.
Correct. Yeah. Correct. So the problem with doing dy, the problem with dx dy, after you integrate everything, and after you substitute the limits in, your final answer is going to have a variable inside. You're not going to get a constant as an answer. You get an answer that still has an x because you are substituting cos x into your answer, the limit. So your answer will have an x somewhere in the answer. So it's not preferable. So that's why you prefer dy dx, because you can substitute the x in earlier, and then when you integrate dx, you can substitute pi over 2 in, and then you will get a number for your answer. Yeah, so we prefer to do dy dx because of this reason. So now, okay, next question. The y limit. Next question is about the y limit. Why did I so as I said, when you do limits, you have to go from a smaller number to a bigger number all the time. Okay, that's how you do your limits. Now, right? Okay. Now, for y, for x it's straightforward lah. 0 is smaller. Pi over 2 is bigger. Okay. Now for y, for y limits, how come I can assume 0 is at the bottom, cos x is at the top? Why is it not the other way around? Why do I straight away assume cos x is bigger than 0? It might not be. If you have sine x, you can have a negative value. Because why? When you do cos x of anything, the answer is always bigger than 0. You test on your calculator. It's
Yeah.
always called, so that's why the bigger one goes at the top. Yeah. So that's why I chose the arrangement that I did. Okay. Okay. So now we decided we are going to go for dy dx, and cos x should be at the top. Okay. So then we've established everything. We can start our integration. Sine x minus y, the integrating. Okay. So we are integrating dy first. So sine x integrate against y. What do you get? Well, sine x in this case becomes a constant. It becomes a number. Yeah. So think of sine x as a number 8. So when you integrate 8, what do you get? When you integrate 8 against dy, what do you get?
Y.
8y, right? Agree?
Yes.
Yeah. Okay. So therefore, sine x, the answer is sine x, y. Okay. Next, minus y. Okay. Now we are integrating y. Integrating y against dy, it becomes y squared over 2. Yeah. And then your limits. Don't forget the x. And then don't forget the x limits. That. Next, then I get cos x and substitute minus cos squared x divided by 2 and 0, 0, 0. Okay, that's it. Okay. Now you integrate this against x, then finish. How do you integrate this against x? Cos x sine x, how do you how do you differentiate cos x sine x? How do you integrate cos x sine x against dx? Well, you need what? Identities, right?
Yes.
Yeah. In this case, can you open your identities list? Tell me what identities you can use. Cos s sine x is equals to what as well? Quick. You can Google.
Minus 1 over 4 cos 2x.
Minus 1 over. Sure as well. What about other people? Let me do it on my phone. Can you be sure? Other people? Product. There's this thing called cos x sine x. There's this thing called the product to some identities. I don't know whether you've heard of this before. When I type in Google, that's what I got given. Okay, have you heard of this before? Product to some identities. So it's like that. There's an identity that says, okay, maybe I Google for you. Where's my Google? There. Okay, there's an identity that looks like this. Okay, where if we have cos and sine or sine and cos, okay, now you can integrate. Now you can integrate this. Okay. Now you should be able to integrate this. So if I start integrating this, yeah, so if I start integrating this, then what do I get? Half, I take out. Sine 2x, integrate, what do I get? Negative half cos 2x. 1 over 4, integrate, what do I get? Well, x over 4 minus the half, the 1/4 I take out. I integrate this, I should get half sine 2x. And then the limits is pi over 2 and 0. Again, I'll do the color for you. Yeah. This is the green. This is the red. Okay.
Sorry, doctor.
Yep.
In the previous step, 1 over 4. How did you get it?
Which one? Wait. Which one over?
The previous step.
Or the previous one?
Yeah.
What this?
Yeah, this one.
Okay. There. I got it from here. I got it from here.
Yeah, but isn't it multiplying 1 over 2 to 1 plus cos 2x over 2?
Correct.
Is it equal?
Okay. So yeah, it's 1 over cos 2x divided by 2. It's like that. It's like that.
Oh, okay.
Yeah.
Yes.
I drew the line too short. It's actually a longer line. So that's why you're actually multiplying. Yeah, you're actually multiplying this.
Okay. I get it.
Okay. All right, good. Thanks for pointing that out because I drew the line too short, so it's a bit confusing. Yep.
Okay, doctor.
All right. Okay. Then you just then so I finished the integration. All you have to do now is You have to substitute your half in there, substitute your 0 in there. The final answer, you finish the rest on your own. Finish the rest on your own. The final answer should be 4 minus pi divided by 8. Okay, you should get this as your final answer. Okay, any questions?
For me, all clear.
Okay, what about other people? Thanks.
Understandable.
Okay.
Clear.
Okay. Okay. So if that's okay, I'm going to go to the very, very last section, okay, which is triple integration. Triple integration is simple. Okay. I only have 2 examples and then we finish. Okay. For the triple integration part, normally, okay, triple integration part, normally, I will give you the limit straight away. Okay. I'm not going to make it difficult for you because the problem with triple integration, if I ask you to draw the region, you remember when we did this double integration, I asked you to draw the region. The region, you always have to do x and y again. And then you, I don't know, draw the region like that, draw the region like that, and then you find the region. Yeah. This is for double integration 2D. Now, the problem is if we do triple integration, I ask you to find the region. Can you imagine what the region is going to be? Well, it's going to end up 3D, right? Yeah, because three variables, it's going to be 3D. Yeah, so very difficult to draw. Yeah, so triple integration, if I ask you to draw region, very difficult to draw. So for triple integration, I'm not going to ask you to draw region. Most of the time, yeah, so for triple integration questions, limits will be given. You just integrate straight away. Okay, no need to draw region. For triple for the triple one. No need to draw region. This is in test and exam lah. In test and exam. In test and exam, if I give you a triple integration question, the limits will be given. You don't have to draw region anymore. Okay, so example is like that. E.g. Okay. So limits given to 0, pi over 2, 0, 3, 0, x, y squared cos z d y d z dx. There. Limits given. You integrate straight away. You integrate straight away. Okay. So what do you integrate first? Well, it's always the inner one that you integrate first. So you integrate dy first, you integrate dz second, you integrate dx last. So what that also means is this is the limit for y, this is the limit for z, this is the limit for x. Okay. So now let's start integrating. So first one, we integrate against y. So x is a constant. Z is also a constant. We just integrate y. Integrate y squared, what do you get? Y cubed over 3, right? Agree?
I agree.
Yeah. Okay, then 3 and 0. Then you substitute this into the y. You get x cos z y cubed. Y cubed. Y cubed is what? 27. 27. Yeah. Okay. And 0 becomes, the whole thing becomes 0 lah. Minus 0. Yeah. Okay. Then you still have dz dx. Okay. Okay. So this equals to 3, 27 divided by 3 is what? 9. Okay, so 9x cos z dz dx. Okay, next, we integrate z. So when you integrate z, what is the z limit? Pi over 2. And 0. Yeah, okay. So next, we integrate these we integrate against dz, yeah? So when we integrate against dz, 9x becomes constant. We just integrate the cos z. Integrate cos z, what do you get? What do you get when you integrate cos? You get sine, right?
Yes.
Positive or negative sign? This is the confusing part.
Positive.
Positive.
Yeah, positive sign, yeah? Okay, good. Oops, so the limit shouldn't be there. Pi over 2, 0. Then you substitute this in there, substitute that in there. 9x. So sine pi over 2 is what? Pi over 2, substitute in sine pi over 2. Sine pi over 2 is what? Yeah. Sine pi over 2 minus sine 0. Yeah, because I substitute 0 in there. So dx. So quick. Sine pi over 2 is what?
1.
1. Sine 0?
0.
Thank you. Okay. Okay, therefore 9x. Yeah. And then the limit for x finally is to 0. There. Okay, so now, okay, can you continue this? This is too easy. Now you just integrate once more against x, then finish. Can you integrate this? Well, let me just finish up for you. 9, so x squared 2, 0. Again, this in, that in. You should get, well, you should get 18 as the final answer. Okay, you should get 18 as the final answer. Okay?
Okay.
Everyone happy with triple integration?
Yes.
What about the rest? How come I only hear one person's voice?
Yes.
Yes?
Yes.
Okay, last example for this entire course. We finish this, we finish the entire course. Oh. Scarier. So again, we do dx first, then we do dy, then then we do dx, then dy is the last. Yeah, that means this is z limits, this is x limit, these are y limits. Okay, looks complicated, but the method is the same. You just need to know how to integrate this thing. Okay, so the first one is dz. The first one is dz. So let's integrate dz. So 2 is a constant, we write it down. Y also constant, we write it down. E to the power minus x, yeah, e to the power minus x squared also constant, we write it down. And then we integrate against z. That means we just put a z in there. Yeah? Everyone understand this?
Yes.
Then you have to substitute your x into z and your 0 into z. So you end up with 2 square root y e to the power x squared times z times x. I put an x in front times x. Okay, and then 0 becomes the minus 0. Okay. Okay. So next, we integrate against the x now. Okay. So the x limit is what? 1 and 0. Next, integrate against x. Now, this is a bit complicated. Why? Okay. Integrate against x. Let's split everything up first. Okay. 2 is a constant. We write it down. Square root y also constant. We write it down. We are only interested in x. We have a x times e to the power negative x squared dx dy. We have x times x, and you have to integrate this. How do you integrate this? X times x. How do you integrate x times x? Integration by what? How do you integrate this?
By parts.
Okay, how do you do integration by parts? Quick. How do you do integration by parts? Quick. Integration by parts, how do you do it? Anyone?
UV minus integrating V
Yeah.
du.
Yep, something like that. Right.
Yeah.
So you have to let u become something, correct?
Yeah. U is X.
Yeah. You have to let u become something. Well, you can do x, but it's a bit tricky. I will let u become something else. I will let u becomes minus x. I will let u become this power, negative x squared. I'll let u become the power, negative x squared. Therefore, when you do du, you get negative. So du is differentiate, differentiate, don't get confused. Negative 2x dx, du dx ma. Okay, so you differentiate the thing. Whoa, let me rewrite this then it's clearer. Okay. I'm gonna let u equals to minus x squared. So du dx is differentiate. You get negative 2x differentiate. Okay, then I can rearrange this to get this. Okay, I can arrange to get this. Now I can rearrange this further to get x dx. Correct. You see how I did this? I can rearrange to get x dx here. Do you know why I want to go for x dx here? Because then I have x dx. Do you see? Yeah, I rearrange to get x dx here. Therefore, I have x dx here. So therefore, this one is constant, so I write it down. 2 square root y is constant. Yeah, don't touch. Let me just write it down. This constant, you don't touch. Okay, so the only thing we touch is the x to the exe. Okay, so now what do you write at the back? Yeah, well, we know x dx is what? D over 2, right? There. X dx is D over 2. Do you see? X,
Yes.
x is x dx is equals to D over 2. Sorry, du over negative 2. So I write du over negative 2 here. And then e, I write e. And then negative x. Negative x is what? Well, negative x, I already said, is equals to u. U. So not everything is in terms of u. So work done. Yeah, well, sorry, not work done. Yeah, so successful. Okay. Now, because I changed all the variables, variable x is now changed to u. My limits x also has to change to u. It cannot stay as x. Yeah, this limit x has to change to u. So you have to convert now. Okay. Now, originally the limit is what? Is 1 and 0, correct?
Yes.
Yeah. So we have to convert to u. Now we know x. We know x is equals to what? Sorry. We know we know u is negative this negative. Well, here, yeah. U is negative x squared. So if x is equals to 1, what is u? Just put this one in there. Yeah. 1 or negative 1? Negative, negative, negative 1, right? Well, you put 1 into x squared, you get 1. But you have a negative in front, so it becomes negative 1. Agree?
Agree.
And then I put my x equals to 0 in there, I still get u equals to 0. So your limits is now, you have a new set of limits, 0 and negative 1.
Sorry, doctor, but isn't it negative 1 square equals to 1?
No. It's negative x squared. So so it's negative 1 squared, like that. It's not negative. It's not this.
Oh, okay.
It's this.
Oh, okay.
Okay.
Yeah.
So now I convert like, because why? Why do I have to convert? Because everything now in terms of u. Therefore, limits have to be in terms of u as well. That's why it's convert. You cannot have the variable u, but your limit still x. Because if that's the case, once you differentiate your u, how are you supposed to substitute the things in? You cannot. One is u, one is the other one is x. Yeah. Okay. So now you can differentiate in terms of u. So 2 square root y. So it's e u. I'm just rearranging. Nothing funny going on. I'm just rearranging. Negative 2 du. Okay. Now you differentiate this with respect. No, not differentiate. Integrate. Integrate this with respect to u, and then you substitute your u variables limits in. EU. Integrate. What do you get? Well, actually the half. Wait, that negative half I can take out already. That negative half I can take out. So I put it here lah. So I put it here. So you're basically just differentiating EU du. EU du. What is EU? When you integrate, what? Not differentiate, integrate. What do you get when you integrate EU? What do you get when you integrate EX?
EU.
Yeah, you still get EU, right? Yeah.
Yeah.
So this 2 and 2 you can cancel out, but you still have a negative in front. You still get EU lah. And then the limits is U equals to -1, U equals to 0. Okay. So can you finish this? You just substitute this U into here, U into there. Can you finish this? Then you just
Yes.
different integrate Y, then finish. Yeah, the Y is easy. It's only square root Y. Yeah. Okay. So that's it. Triple integration. That's it. Do I have another example for you? No, no more examples. No more examples. Okay. So so that's it. For the entire course, we finished the entire course. So Monday holiday. Okay. So have a good holiday. So I will see you on Friday, face to face. In if the test is on Friday. Do you want Friday or do you want some other time?
Can you make it on Monday if everyone agree with me?
Well, it's holidays, right?
No, I mean the week after holiday.
Oh, the week after holiday is study leave, right?
No, we will be still in week 14.
Oh, yeah, kah?
Yeah.
Okay. So week 14. Week 14 Monday, huh?
Yes.
Okay, lah. Okay, week 14 Monday. Okay. Test 3 and 4. It will be the multiple variate differentiation and integration, multi-function integration, the multiple integration. Okay.
Okay, doctor.
And then after the test, maybe the week after maybe after the test on Monday, on Friday, we will have a short revision class. Okay.
Okay.
So test. So let me just write down. Test 3 and 4. Test 3 and 4. Twenty-4th of June, right? Yeah. We start at 8:15 lah. We start at 8:15. Okay, and then revision class will be on 28th. Online. Okay.
Okay, doctor.
Okay. So right. So hang on a second while I do the attendance. Copy link. Okay. Okay, if you go to the message box, okay, I shared attendance there. Try to do it, see whether it works or not.
Ready, doctor.
Okay, All right. Okay, so if that's okay, make sure everyone do the attendance by 12 o'clock noon. Otherwise, it's gonna expire. Don't message me if you do it late. All right, so I will see you. So next week, no class at all. Okay, I will see you on the 24th for the test.
Okay, doctor. Thank you.
All right.
Okay, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.